Hello, welcome back. For this video, we're going to discuss solving multi-step equations, and this is going to come from lesson 2-3. You can see what today's goal is to solve equations involving more than one operation. The key on this one, though, is the variable is going to stay on one side only. And, of course, vocabulary is going to be multi-step equation. Right here, we have a definition for multi-step equation that uses more than one property of equality to solve it. For this type of equation, you can undo each operation using properties of equality. Working backwards in the order of operation, that's actually key right there. Working backwards in the order of operation makes that process a little bit simpler. Each step results in equivalent equations. Now, here are 3 steps that I created a long time ago for solving multi-step equations. There's 3 steps on here. Step 1 and step 2 we are not going to use today because we're keeping our variable on one side of the equation only. But we will do step 3, which is to isolate the variable of interest by applying PEMDAS in reverse. So that's order of operations in reverse, and that's going to be key. For our first example here, we want to use properties of equality to solve each equation. When we say solve, we mean we want to get the variable a by itself. And what that means is the last calculation to go will be the one that's directly attached to the variable. So the first thing we have to undo is the -6. And its inverse operation here is going to be +6. So +6. And to make it a property of equality, we have to add it on both sides. So we're going to put equal sign there. So add 6 to both sides. Remember, this right here will give us a 0. And 0 plus the 2a is an identity. So we end up with 2a. Now, another way of calling this +6 and -6, instead of saying inverse operations, they're also additive inverses. It makes it +0 to the problem, which drops out. Bring down our equal sign, and then, of course, we got to simplify this. 4 plus 6 gives us 10. Now, the last thing we want to do is undo the number attached to the a right here, and that's attached through a multiplication. So we're going to undo that one of 2 ways. We're either going to divide both sides by the 2, or multiply both sides by the reciprocal, which is 1/2. And most students prefer to divide by 2, so I'm going to divide by 2 here. So to keep this equal, I got to use the division property of equality, which is 2. Divide by 2 there. And 2 divided by 2 gives you 1, and 1 times a is an identity, which gives us a. Now, another way we could have wrote this over here is to times it by the reciprocal of 1/2, which is multiplicative inverse, which is going to give us 1. The whole point here is to get a 1 out in front of a. 1 times a is just a. And the right-hand side is just 10 divided by 2, which gives us 5. Okay, for this next example, we have the variable in the numerator. And I think I've mentioned before that you need to treat numerators like they're a grouping symbol, which means you have to get rid of the denominator here first. And the denominator is dividing. It's dividing by a -2. So to solve that, we're going to first undo that division of -2 with the reciprocal operator, which is times a -2. And on the right-hand side, we're going to also times by -2. And then -2, on the left-hand side, -2 times, and then divided by -2 gives you a +1. And +1 times n plus 1 leaves you with just n plus 1. So effectively, the 2's here cancel out because of the multiplication property, identity property of multiplication. This becomes a 1. On the right-hand side, we have a 15 times a -2, which will give us a -30. And then the last step is to get rid of the +1, so its reciprocal operator is subtraction, where its additive inverse is -1. So we're going to -1 from both sides, put a little equal sign there in the middle. This is going to zero out, leaving us with n plus 0, which is an identity. Leaves us just n, and then -30 minus 1. Be careful here, this is not 29 or -29. The answer here is -31. You might want to pause the video and try both of these checks, so the first part and the second part. Okay, so now let's go ahead and try and solve this. So I've got 3m plus 4 equals -11. Whatever is attached directly to the variable, I'm going to do last. So I'm going to undo the +4 first. So I'm going to -4 from both sides. Those are subtraction property equalities, or you can also call it the additive inverse. This will zero out, leaving 0 plus 3m, which is 3m. And the right-hand side is negative 11 minus 4, which is negative 15. And then undo the 3. I'm going to do the reciprocal now. I'm not going to do the division. I know a lot of people like division, but you need to get used to reciprocals. So I'm going to multiply both sides by the reciprocal of this number I'm trying to eliminate. So the reciprocal of that is 1 over 3, 1 over 3, so I'm times on both sides. 1/3 times 3 gives you 1, and 1 times m is just m. So it's effectively the 3's will cancel out to a positive 1. On the right-hand side, I have a negative times a positive. That's going to give me a negative. And if I multiply them out, you actually will get negative 15 over 3, which reduces to negative 5. So m should equal negative 5. And yes, you are supposed to go back and check your work. To make the video shorter, I'm just going to move on to the next one. We want to solve this one, and this one is 8 is equal to x minus 5 over 7. Now we want to get rid of the denominator first, because the top and the bottom are actually supposed to be like groups. So we want to get rid of the group on the bottom first. And the way to get rid of that is to multiply both sides by 7. Multiply both sides by 7. Now when you multiply by 7 on this side and then turn right around and divide by 7 there, these will become a 1. And 1 times this whole thing there, that x minus 5, is just going to leave you with x minus 5, because that's an identity. 1 times anything is an identity. Left-hand side is 7 times 8, which is going to give you 56. And now the only thing left to do is undo the minus 5, so we're going to add 5 to both sides. And we're doing properties of equality here. And now we have, this is a 0 plus x, which gives you x. And then 56 plus 5 will give you 61. And you should go back and check your work to make sure that's accurate. Example 2, we want to write and solve a multi-step equation. This is coming from a word problem, and writing equations is one of the most difficult parts of algebra, not actually solving them. So we have fundraising. The student council raised 2/5 of the money, so 2/5 of, and of means times, that they need to cover the cost, so it's some kind of cost of the dance for the bake sale. They raise an additional, so additional means they're increasing, 150 by selling raffle tickets. If the student council has raised 630, this sounds like a total amount. Write an equation for the problem. What is the cost of the dance? The question is, what is the cost, right here, what is the cost of the dance? So that's going to be your unknown. They want us to write an equation for the problem, then solve it. So down here they have C equals the cost of the dance. Because if you look back up here, the question is, what is the cost of the dance? That's our unknown, so that's going to be our variable. Also up here, remember we said there was 2/5 of the money needed for the cost. So 2/5 of the cost. So how do we show 2/5 of the cost? Remember, of means multiply. So it's 2/5 times C. Plus the additional 150 that they sold with raffle tickets, so plus 150, is means equals, so we're going to put equals 630. Now they did want us to solve it to find out what the cost of the dance was, so what the cost of the dance was. So we're going to solve this equation, 2/5 C plus 150 equals 630. So when we solve this, remember the number that's directly attached to the variable, which is that 2/5, will go last. So we're going to undo the 150 first by eliminating it from both sides. So minus 150, minus 150, that's a subtraction property of equality. This zeroes out, so using additive inverse always gets you 0. And 0 plus 2/5 of C leaves you with 2/5 of C equal to, now 630 minus the 150 is going to leave you with 480. Now this last step here, you can actually get rid of the numerator and denominator separately in 2 different steps, but let's go ahead and do it in one step. So we want to undo the times 2/5. So instead of dividing by 2/5, because we can't really divide, we're going to actually multiply by the reciprocal to make it become a 1. Remember, that's the multiplicative inverse. So the multiplicative inverse of 2/5 is 5/2. And when I multiply these two things together, I get a value of 1. And 1 times C is equal to C, so I have C down at the bottom. But don't forget, I multiplied this side by 2/5. That means I need to multiply this side by, 5/2. I got to multiply this side by 5/2 as well. Now I'm going to put a 1 under here as a placeholder. You could multiply straight across and get a very large number and then reduce it. I like to reduce it first on a diagonal. So 480 divided by 2, so 480 divided by the 2 here gives me 240. And then I'm going to multiply that by the numerator value that was still left over, which is 5. So 240 times 5 gives me 1,200. Now this is in dollars, so I'm going to put a dollar sign on it. So that's $1,200, which is the, if we look back up here, cost of the dance. So C stands for 1,200, and 1,200 is the cost of the dance. Go ahead and pause the video for a moment and attempt to do the check here. Okay, so in this basketball problem, a sporting goods store sold 2/3 of its basketballs. So 2/3 is an important number, and of is an important word. That means multiply 2/3 of its basketball. But 8 were returned, so 8 of them were returned. Now the store has 38 basketballs, so they have 38 remaining on hand. How many were there originally? So they're talking about basketballs, so that's the question, how many they were originally. So since we're talking about basketballs, I'm going to say let B equals original number of basketballs. So that's originally how many they had. Now we need to interpret something here. It says the store has 38 basketballs. That's 38 remaining. So they have how many remaining? And that should be the result or equal to how many they have left over from their sales plus what they had returned. So plus return. And then the first one up here is remaining from sales. So this one's the remaining amount. This is where it gets a little difficult. The returns is easy, so plus 8. And how many they had remaining was 38. How many remaining? Your first instinct is to take the 2/3 and times it by the number of basketballs. But remember, this is how many they sold. So 2/3 of the basketballs were sold, meaning they're no longer there. What we want to do is how many are remaining. So if they sold 2/3 of the basketballs, then that means there are 1/3 of the basketballs remaining. So you have to kind of figure that out intuitively. So we have remaining is actually 1/3 basketballs plus 8 equals 38. And if we look at their answers, we have two options, A and C. Now we have to divide or solve for B to figure out which one's which. So the first thing we're going to do is subtract 8 from both sides. We have 1/3 basketballs equal to 38 minus 8 is 30. And then to get rid of the 1/3, I'm going to multiply both sides by the reciprocal or the multiplicative inverse, which is 3. So that I end up with a 1 over there. So 3 times a third is 1. 1 times B is B. And 30 times 3 is 90. So we have 90 basketballs, which gives us choice C. Example 3, solve a multi-step equation with letter coefficients. Okay, so some equations have coefficients that are represented by letters. To solve these equations, apply the process solving equations to isolate the variable. So looking at the problem that we have, ax plus 7 equals 5. We want to solve for x, so I'm going to underline that. We're going to solve for x, assuming that a does not equal 0. So we're going to solve it as if a was an actual number, but since a is a variable, there will be a variable a left in the answer. So the first thing we're still going to get rid of is the plus 7 because the a is attached to the x, and the x is what we want to isolate. So we're going to get rid of the 7 by minusing 7 on both sides. Okay, that's the property in the subtraction property equality, also the additive inverse. That gives us 0 here, leaving us 0 plus ax, which is just ax, that's an identity. And then 5 minus 7 is going to give us a negative 2. Now we want to get rid of the a, and the a is multiplying with the x, so the reciprocal operator of multiplying is divide, so we're going to divide both sides by a. A divided by a, whatever the value of a is, as long as it's not 0, is going to give you 1, and 1 times x is x. So the final result here is just negative 2 over a. Now, instead of dividing by a, you could have multiplied both sides by 1 over a, which is the reciprocal, and that would have also worked. Go ahead and pause the video for a moment and check this last answer. Okay, let's go ahead and solve. We've got 2 minus ax equals negative 8. Again, we're going to solve for x, assuming that a is not equal to 0. And the reason we can't have it equal to 0 because when it ends in the denominator, you can't divide by 0. All right, so we want to get rid of the 2 first. The a is attached to x with the negative sign, so that's going to go last. So we want to get rid of the 2 first. The 2 is positive, so I'm going to get rid of that with a negative or a subtraction. So I'm going to divide both sides by, or subtract both sides with a negative 2. So already subtract the 2. So 2 minus 2 gives us a 0. And 0 minus ax is going to give you a negative ax. And negative 8 minus 2 on the right-hand side is going to give you a negative 10. Now we want to get rid of the a and the negative, not just the a. We want plain old positive 1x left over. So I have to get rid of the negative. So I'm going to divide both sides by negative a, and negative over negative is a positive. A over a is 1, and 1 times a is, or times x is an identity, leaving you with x equal to. Now over here, we're almost done. The only thing we need to change is negative over negative is a positive, so this should be 10 over a. So x equals 10 over a, which is D.